Schistosomiasis is a neglected tropical disease that affects 200 million people and accounts for 100,000 deaths annually. In endemic geographical areas, schistosomiasis has been implicated as an etiological agent in the pathogenesis of bladder, colorectal, and renal carcinoma, largely due to schistosoma eggs in tissues that comes with chronic infection. The role of infectious diseases in the etiology of prostate cancer is largely unknown, and it is an important global health challenge. It represents the highest form of cancer and the commonest cause of cancer death in men. About 99% of prostate cancer cases occur in men. It occurs with above the age of 50 years old, characterized by painful urination, blood in urine, frequent urination, and sexual function disorders. Despite the overwhelming escalation of the diseases and its burden globally, much is not known about its etiology. However, factors such as old age, race, genetic, and environmental factors are suspected to increase the risk of prostate cancer. Earlier studies have revealed the presence of estradiols in schistosoma eggs and implicated them in the pathogenesis of cancer via an oxidative stress route. Enzymes including cytochromes P450 and peroxidases metabolically oxidize these estradiols into highly reactive chemometabolites, and then there is a production of GSH, which in turn causes the catechol estrogens. The accumulation of chemometabolites leads to depletion of GSH and the accumulation of GSSG, which leads to stress condition, and estradiol chemolones will already accumulate, and then depurinating adducts, which increases in cell proliferation. Oxidative stress leads to the loss of mitochondrial membrane potential and cytochrome C release from mitochondria to cytosol. This both causes caspase-9 dependent activation of caspase-3, leading to cell death. Another study says that the inactivation of B27 plus the upregulation of BCL2 leads to cell proliferation and will inhibit apoptosis. Caspases initially exist as cyanogens but are activated by proteolytic cleavage of specific fragments. They are classified as initiator caspases 8, 9, 10, and effector caspases 3, 6, and 7. Caspase 3 is an effector caspase which upon activation mediates apoptosis by cleaving PARP or poly-ADP ribose polymerase, a protein which plays a key role in cellular assembly and is involved in repair of single-stranded DNA breaks. Activated caspase 3 activates the cytoplasmic endonuclease CED or caspase-activated DNAs by cleaving off its inhibitory subunit ICAD or inhibitory of CED. Activated CAD translocates into the nucleus and cleaves DNA into internucleosomal fragments and induces nuclei condensation or shrinkage, morphological phenotype characteristic of apoptosis. Schistosoma species soluble egg antigens induce oncogenic phenotypes including oxidative stress, increased proliferation, and diminished apoptosis. In cultured normal human prostate cells. This study, for the first time, has provided empirical evidence on the possible role of schistosome infection as an etiological agent in the pathogenesis of prostate cancer.